So my name is Axel Georgette. I'm a machine learning engineer at Actable AI, and today I will make this quick presentation, quick class on data cleansing, imputation, and other data manipulations. Um, so we'll start with a brief introduction to SQL, SQL language. So with basic data filtering, joins and grouping, and we'll follow this by a data cleansing introduction as well, where we'll see how to remove duplicates and how to handle outliers in our data, to finish with data imputation, where we'll learn how to handle missing values and invalid and misplaced values as well. Okay, so let's start with SQL. But before that, let's remind ourselves what is a database. I'm sure most of you guys know what it is, but it's never bad to remind ourselves about this. So basically, databases are here to just store data. So it's an organized collection of structured information, data. I'm emphasizing here about the structured information. It's not, I mean, usually it's the data is well structured as tables. So the most common way is to have just columns and rows, basically. And SQL is a language that helps us to manage that data in relational databases. So you might have heard of MySQL, PostgreSQL, PostgreSQL. There are many others. Those are databases, and they are using SQL to, well, organizing, altering, and exploring those databases. So yeah, this is a SQL, and we'll see how to mainly explore data using SQL. So there are some statements, basically. So the first one and the most important one is the select statement. So it is here to see the content of a specific table, basically. So here I'm showing the syntax of the select statement. So the first line we can see here, we can see that we are selecting some columns from a table name. So it's quite easy to read. Select column from table name. You can also replace the different columns here, column 1, 2, 3, by just a star to select all the columns. So this is the main SQL instruction, and it will always be used when we are exploring data in SQL. So here's a quick example. So we have this table, so this data in the database, and so the table name is called can. And here we can see that if we do select star from can, it will show the whole table with all the columns. Now let's say we don't want to have the ID here, so the first column, we can only select the name and the capacity. So for that we just do select name, comma capacity. We name it capacity here from can, and here we are. So this is like basic but very important. And from there, from the select instruction, we can add more statements. So for instance, here we have the where statement. So this is here to basically add conditions on what we want to get, what we want to select. So we still have the same syntax, select columns from table name, but then we add the where statement. So where, and then the name of the column and equals value, for instance. It could be also greater or equal or different, things like that. And you can add multiple conditions by separating them with or and. So those are quite basic, but it's quite useful. So if we go back to our example before, I'm showing the table again. Let's say we only want to select one row here, the row with the ID 8. Well, we can use the where statement and do that. So select name capacity from can, where ID equal 8. And so this way we only have the water here, and that's it. So we can filter here, and you can imagine how useful that is on big data sets. Great. So now let's talk about the order by. So order by is here to to basically order the selections. So the results we see by default is ascendant, but you can also add the DSCC, at the end to invert that and have descendant order. So yeah, same syntax, you just add the order by at the end, the column name, which you want to order, and desk if you want. But you can also add multiple column names as well if you want to sort by multiple columns. So here we have another example. So we have a table with first name and last names. And here when we print the data from the table, well, we basically order that by last name and first name. So quite straightforward here again. So select first name and last name from student. So the table is called student. And then order by last name and first name. In the case where we have the same last name, we will then order by the first name. So, quite straightforward again. Okay, so this is great. Now let's move forward to the joins. So the joins are here to get information from several tables at the same time. And so basically it goes into two steps. First, we do a Cartesian product, which is going to link all the elements of one table with another one. And then after that, we do a restriction on this product, which will eliminate all the elements that do not respect one given condition. So yes, this is the main principle about join statement. We'll see how we can use that just after. But first of all, we also have to remind ourselves that there are three different types of joins. So inner, outer, or cross. Now let's see. So first, the inner join. So the syntax here is the following. We still select, so here star to represent all the columns from A. So we have a table A. And then we say inner join B, so table B, on, and on here is the condition we were talking about just before. And so here we want to select everything with the ID B equal to the ID. So here we say a.idb to say the column IDB in the table A must be equal to the column ID in the table B. And so if we look at the schema, right, I mean the diagram just below, we can represent the tables A and B as just circles, and we will just select the intersection in the middle where the IDs are equal. We'll see examples just before, just after, but first let's continue. So we also have the left outer join right here. So it's the same principle, but instead of saying inner join, you just say left outer join. And this is what it looks like. So it will select basically everything from A and add to this the information on B where the IDs are equal. Same principle for the right. So instead of this one, we select this one, the B one. And the full one selects everything, basically. And finally, we have the cross join, a little bit less used, but quite important as well. So the cross join is just a Cartesian product again. So here we can represent here in the schema, we have the first on the left hand side, the table A with A and B inside, and we have the table B with 1, 2, 3 inside. And the cross join will give us all the possibilities basically. So A1, A2, A3, B1, B2, B3, etc. So yeah, this is for the joins. And we'll continue with a group by now, just before going to the presentation. So, I mean the tests. So the group by here is to regroup the results of a select request. And so basically it consists in merging several rows into one using aggregate functions. So here's the syntax. Again, we still have the select from, and we add the group by at the end. Pretty simple, again. And instead of the column here, you will have to replace them by aggregate functions. So let's look at aggregate functions. So they are here to basically compute, to get one value out of multiple values, values from several rows. And the most common are like the count, the maximum, minimum, sum, and average. So what it does, for instance, the maximum, it will give you the maximum number, maximum value, out of multiple values in the group. So it might not be very clear. So let's look at an example here. So we have this shopcam table. So here we are putting the shop ID and the price. So we can see multiple shop IDs and some prices. Now we are going to group this table by shop ID, meaning that we will have one row per shop ID and that's it. And for this, we'll use an aggregate function to regroup the prices together. So let's look at what we do here. We do select shop ID and max price. So this is the aggregate function max from shop ID, shopcan, sorry, and then we do group by shop ID. Great, and that gives us one row per shop ID with the maximum value, so the maximum price basically. So for the shop ID 3, it's 1, shop ID 2 is 1.2, and 1.1 for the shop ID 1. So this is for the group by. So now we've seen I would say, the most important SQL statements and the syntax. So those are like the base ones. There are more advanced SQL things. You can also create tables with SQL. You can alter tables, but we'll stay here for now. Just before moving to the demo, we'll just talk about the remove duplicates that needs to be done in some data cleaning process. So sometimes in databases you have duplicates rows, and this can be a problem. So sometimes you want to remove them. For this, SQL has this distinct statement, and so you add it basically after the select, and it will, well, only give you the results which are not duplicates. Okay, so let's move to a demo here to refresh all of this. So with our Actable AI tool, we have what is called the SQL Lab. So if I can show you from the main page, Actable AI. On the left corner here, you have the SQL Lab. I don't know if you see right here. So when I click on it, well, I have my SQL Lab here. And I can play with SQL right here. So here I started with a simple statement, a simple SQL query, where I'm selecting all the columns from the apartment dataset. So apartment is a table name, right, as we've seen in the syntax. And the result is right here in front of us. So we can see we have the number of rooms, number of bathrooms, square feet, location, days on market, initial price, neighborhood, and rental price. So those are all the columns we have. Great, so now let's, just as we've seen in the slides, let's try to make a bit more complex query. So let's select only a few columns here. Let's say we are interested in, well, days on market, for instance, initial price. Let's say we want to have the location and neighborhood as well. And finally, the rental price. So I'm just basically selecting some columns out of those, not all of them. So you see I'm not selecting the number of rooms or bathrooms, neither the square feet. And if I click run query, we can see that we only have the columns we've requested and in the order we've requested them. So this is great. Now let's filter this a little bit more. So let's see. We can see we have the location column here, and let's say we only want the great location. All right, so let's do that. Let's do where location equal to, well, let's say great. Okay, let's run this and see. So here we can see it filtered out everything that is not great. So we only have the great locations. Amazing. Now let's continue. Let's say we want to have the results in a specific order. Let's say we want to have the longest, the locations, the places, the apartments, sorry, which have been on the market for the longest time. So let's sort this. So let's sort this. So as we've seen here in the slides, it's order by. Okay, order by. So let's put days on market here, and we want to have the the longest days first. So let's add descendant. To have the order inverted. So let's run query, and as we can see here now, it's ordered by days on market. Well, that's great. Now let's say we want to have the I mean for the apartments which have been on the same days, and I mean same amount of days on market, we want also to sort the initial price. So here we can see that there are many apartments which have been on the market for 14 days, right? And I want to sort this initial price as well. So let's add that. So order by days on market and then initial price. Great, let's run this. Oh, sorry. So here we can see it didn't work. So it sorted the days on market in the ascendant order, but the initial price in the descendant order. It's because I need to add descendant to every column. So it's like this, basically. Days on market, descendant, and same for initial price. Great. By the way, if you have any questions, please interrupt me. I'm not seeing the chat right now, but yeah, don't hesitate to speak up. Great. So as we can see here now, we have the days on market first, I mean the longest days on market, and then the highest initial price first. So this is for the ordering. Great. Well, now let's continue. So after the order by, we've seen the joins. So let's do some joins here. I will comment this and show you another table which I have. So basically, I have a small table, a very small table. You can look at it. It's called neighborhood city. Okay, neighborhood city. And so if we look at this table, run query, we have some neighborhood here and some city corresponding to the neighborhood. Great. Now I want to, I mean, if we look at our apartment dataset, just we had before, so let's put that back, sorry. Okay. We see that we have the neighborhood. You can see that we have the neighborhood, but we don't have the city though. So here, this is a use case where the join can be useful. So let's just show all the columns here, select all, and we can see that we have many columns, but we don't have the city. So we have another table which contains the city, but now let's use join to, well, have the city as well in this query. So for this, we can use the, let's say, inner join, and we can say neighborhood city. And like we have to precise on which column, so on. And so here we want to have the apartment.neighborhood basically, sorry, equal to the neighborhood city.neighborhood. So this is referring to the column neighborhood in the apartment table, and this is referring to the neighborhood column in the neighborhood city table. I hope this is clear. Please interrupt me if it's not. Great. So now I just have to say, to precise which neighborhood here I want in the select. So I can put apartment.neighborhood, and I want also the city. So let's add the city right here. Great. So this should work. Let's look at the results, run the query. Great. So we have the same thing as before. It's still sorted. We still only have the great locations, but on top of this, we have the city on the most right column. So great, we've seen inner join. So I will not demonstrate the other type of joins, but I think you get the idea. I just now want to group by my results. Great. So it's a bit of a complex query here. So I will start from a new one. So let's comment this. Okay. So I will stay with the apartment dataset. So select all from apartment. Great. So we have this. Now I would like to see some statistics, and I would like to, let's say, group them by neighborhood. So I want to have one row per neighborhood, as we've seen before. And I want, let's say, to have the average initial price per neighborhood. So we can start by, let's look at the initial price in neighborhood like this, maybe to start. Great. So here it's not group by yet, but I want to have the average initial price. So I'm going to use the group by statement as we've seen before. So group by, well, neighborhood, great. And as we've seen, we need to use an aggregate function. So let's use the average, avg, great. So average of the initial price, amazing. So run query. And so right here, we can see that for each neighborhood, I have the average initial price. And we can actually see that it varies quite a lot depending on the neighborhood. Great, so this is a demonstration of the neighborhood. I also forgot to talk about the distinct, to remove the duplicates. So let's look at this. Again, I will start with a new query. So it's going to be fairly simple. So let's select the neighborhood and the location, for instance, from the apartment table again. Great. So here we have all the neighborhoods and the locations. But I'm sure there are duplicates. We can see here like Southside, great, there are 3 of them. I want to remove those duplicates. So we just have to add distinct in front of it. So select distinct, run query, and here we have the unique selections. Great. So this was a quick demonstration of some SQL, the SQL you've learned right now on our app, so on the SQL lab of Active AI. Now let's move on. Great. So if anyone have any question, again, please stop me. All right. So let's talk about data cleaning now for real. So we've seen how to remove duplicates. Now let's talk about outliers. So in datasets, usually we might have outliers. So outliers can be wrong data, like data which make no sense, or data which are too high. But anyway, some statistics and machine learning models can be very sensitive to those outliers, in the sense that it can impact the performances quite badly. So first of all, we need to detect those outliers. In order to do so, we might plot the data, for instance, using Boxplot, histogram, or scatterplots. We may also compute what is called the z-score. So the z-score is giving us the number of standard deviations by which the value of a data point is above the mean of the observed data. So I won't go into details here, but basically, the higher the z-score is, the further it is from the mean of the observed data. And we can, this way, detect data points with a z-score which is too high, and so detect the outliers. And then how do we, handle those outliers we've just detected? So you might just delete them, but this is not always possible, unfortunately. For instance, if we talk about time series datasets, well, removing the outliers might mean removing some data you actually need for the forecasting. So you cannot do that all the time. For the outliers, sometimes you might delete them, but this is not always possible. So when it's not possible, you might also just replace them. This is called, using data imputation. So we'll see that just after. But before, I would like to show you some plots which are helpful to detect the outliers. So here we have, I've been using a dataset called data scientist salary. So it shows basically salaries for data scientists in the US for different type of data scientists, let's say. So this is the dataset we can see in our app on Active AI. So there are many columns, right? But we are going to be interested in 2 columns particularly. So the job title right here, and the average salary, which is right here. So if we plot that using a box plot right here, so actually I can do this with our app, we can see we can see some useful information. So first of all, on the x-axis, we can see every job title. So data scientist, project manager, analyst, data analytics, etc. And the y-axis represents the salary in thousand. And here, an interesting outlier we can see is this data scientist. We have this yellow point at the very bottom, which seems a bit off. So this can be considered an outlier in the sense that it doesn't make much sense to have this data point here. Just a quick recap about Boxplots. We can here see basically the distribution of the salaries for each job title. So if we look at this data scientist one, so the yellow one, basically we have the median, which is at 113. We have the mean and the maximum, and we have the first quartile and the third quartile here, basically. And then we have those outliers, those points at the top and this point at the bottom. So it depends on how you want to consider outliers, but those at the top can be also considered outliers. But this bottom one don't make much sense. And we can also see that using an histogram. So here is an histogram again with the average salaries. And so basically it counts the value for each salaries. So for instance, this bar here shows that there are 21 values with between 87 and 88. So this shows yeah, this distribution basically. And we can see here at the left we have one very alone, let's say, bar, which is an outlier basically. The one at the very right here can be also considered to be an outlier. So if we go back to the slides, yeah, we have so we have this box plot, and we can see this outlier here, and same here. So this is important as a first step to detect those outliers. And then if you want to remove them, for instance, you can use SQL as we just seen. Using the where filter, you can basically choose to remove some data points. So yeah, this is for the outliers. Now let's talk about data imputation, and more precisely the missing values. So you might have some missing values, which can be non-values or just I don't know, something else in your datasets, and those can reduce your model quality. So there are many ways to deal with those missing values. You can just remove them from your datasets, but sometimes you want to impute them. And so to impute them, you have different methods. For instance, you can replace those missing values by the mean or the median, or by the most frequent values, or by a constant, let's say 0, for instance. And then you have more complex solutions, for instance, using KNN. I won't go into details into this one, but there are other methods. And also we have Actable AI, we have our automated machine learning tool, which will automatically replace those missing values. All right, using advanced machine learning. And on top of those missing values, sometimes you have values, but they are incorrect or incoherent. So those outliers, for instance, can be considered to be incorrect values or incoherent values, right? And so yeah, the reason for those can be multiples, but usually it's mistakes when we annotate the data or when we gather the data. I mean, it can come from multiple sources, but well, when we have them, it's important to treat those invalid values, basically because well, you most likely don't want an invalid data set, but also because it can improve the correctness of your analysis and well, the accuracy of the models you might train with those data. So how do we handle those invalid values? So basically, Actable AI here is offering a powerful tool for this data imputation. So what it will do is it will suggest fixes for the missing values and the invalid values. And so here I will show you an example. in our app again. So we have this data set right here. So this data set represents hospital data, yeah, with many columns, but we don't need all of them. So we can see that there are, well, some missing values here in the address, the samples, for instance. And there are also some incoherent values. So if we look at the phone numbers, I don't know if we can see them here, but yeah, sorry, there are a lot of data here, but I know there are some incoherent values. So, well, I've run a data imputation on this dataset with our tool. So basically, we have our dataset here, and here we can go to data imputation. So this is one of the analysis we can do. I've run it beforehand because it takes a bit of time to run. But what we can see here is that it replaced in yellow the missing values. So we can see that before it was null. And yeah, it replaced the values with our automated machine learning. And also, because we added a rule, we removed invalid values. I mean, we've not removed, sorry, we've fixed invalid values. So when I'm saying invalid values is in the phone numbers. So where is it? Sorry. Give me 1 second. Okay, so we should have the phone number column right here, and we can see there are some yellow yellow values. It means that the algorithm fixed those values. And if we put our mouth onto, our cursor onto this phone number, we can, it's a bit small, sorry, but we can see that before there were an X in the phone number, and it has been replaced by a correct phone number. And so how did we do that? Well, with our tool, here we added a rule. So if I add a rule right here, that's what it does. And so the rule is the following. So when we have hospital name equal to hospital name, then we want to fix where the phone number are different. So I realized this is not really clear. So basically, in the dataset, we have hospitals and we have phone numbers. And for each hospital, every hospital should have the same phone number, right? So that's what we represent here. We say to our data imputation that when the hospital name is the same, we don't want the phone number to be different. And so here, how it will be handled is our algorithm will find every phone numbers which are different when the hospital name is the same to replace this phone number using automated machine learning. We can also do the same with misplaced values. So misplaced values represents values which are incorrect. Let's say for the phone number, again, we can say that we want it to be, let's say, different than 0. So if I do this, the algorithm will consider that every phone number which is equal to 0 should be changed. I won't run it here because it will take too much time, but this is how it works. Great. So yeah, that's it for the data imputation. So yeah, to finish this quick class, I would like to remind yourself that we have some more advanced class coming next week. So next week is predictive analytics with machine learning. So yeah, I invite you guys to attend. And yeah, if you have any questions, please feel free to ask.